Good morning. So in previous class we have seen some of the basic elements like identifier and two objects we discussed already, the constants and variable. First of all, coming to identifier. So what is identifier? Of course we discussed in previous class, but before going to see the other data objects like signal and file. Okay, so once again I would like to discuss what is identifier, what is constant and what is variable. So identifier means, identifier we can define as a group of characters or a sequence of one or more characters referred as identifier. And what is the purpose of identifier? It is used to give the names for different units like entity, architecture, configuration, package, signals, variables, constants, like that. Wherever user defined name is there you can use the identifier. But the identifier allows all letters A to Z, digits 0 to 9, but a special character underscore only. A special character underscore only it allows. And rules which you have to follow while giving the name or preparing the identifier is, it should start with letter A to Z only, not end with underscore. Successive two underscores not used, space not allowed, keywords, reserved words, whatever in the language, they should not use as a identifier. Okay. Then coming to object. So data object it holds a data of specified type. So whatever the data the user can mention, the object can hold the data. But in the language we have four classes of objects. They are constants, variables, signals and files. Coming to constant, as the name specifying, its value always fixed, constant. The object which is declared under constant, whatever the value it holds, that is fixed always. It may not change, it never change. But coming to variable case, the object which is declared under variable object, the value of the object may change during the simulation period. So that is a thing about two types of data objects and identifier. Now coming to other data objects like signals and files. Coming to signal, first of all, signal data object purpose also holding the data of specified type, but here also the value is changed during the simulation type like variable. So in case of variable, the value is may be changed during the simulation time, that depends on the program. Similarly, programming technique. Similarly, the signal value also may be changed. But what is the difference between constant and the signal declaration says? The constant declaration, sorry, not constant, variable declaration is used in the process only. The variable declaration and variable assignment is used in the process statement. Okay, one of the concurrent statement in the architecture body is the process. There the variable object is used, but signal object is used in the architecture body mainly. Okay, and whatever the objects declared in the entity, they are automatically treated as signals. Okay, so I think this is a global one, signal is, but variable is local, that is used only in the process. Let us see what is the syntax for signal. It is similar to variable declaration, that is signal, start with the word signal, signal name, colon, type name, colon equal initial value, colon equal initial value. But the initial value is an optional one, that you can assign initially a value to signal object or not. Signal name is a user defined name, that is it is identifier. It is identifier. Data type is what type of data. Okay. So let us see some examples for this signal declarations. Coming to first example, signal x bit, signal x colon bit. What does it mean? X is an object of type signal. It can hold binary type of data. Since the data type mentioned here is bit, bit is a predefined data type. It has two values, 0 and 1. Those are the binary bits, right? But the X can accept only one bit data at a time, either 0 or 1, that's all. But coming to second example, here a signal y colon bit vector of 1 to 5, bit vector of 1 to 5. So what does it mean is y is also an object of signal. It can also hold binary data because the data type is bit, but more than one bit it can accept. But how many bits? 5 bits, because it is represented with the data type bit vector. Bit vector, if you want to assign more than one bits, bit vector is used with the range, that is 1 to 5 mentioned here, so 5 bits are used. Similarly, coming to third example, signal y bit vector of 6 down to 0, 6 down to 0. That means y also a signal object can hold binary data. So each binary data can has 7 bits here, 7 bits. So both are both the second example case and the third example case, the object can accept more than one bit. But still, what is the difference between these two is, in the second one case, y of 1 is the MSB bit, y of 5 is the LSB bit. But in the third example case, y of 6 is the MSB and y of 0 is the LSB. That is the difference in these two declarations. Clear? Signal is an object. It is declared using the word signal followed by signal name colon type name then initial value. Okay. Then let us see another object one is, that is file. Okay. So file also a data type, sorry, data object. Okay. Its declaration is declarative syntax is start with the word file. File names. File names means more than one name you can use by separating comma. Not only in file case, in object, in constants case, in signal case, in variable case, you can use more than one name. Okay. Colon file type name. So file type name is type, what type of data. Then open mode. Open mode. Open mode, that is this file is ready to accept the data, that is from the file you can read the data or you can enter the data. Okay, read and write operations are mentioned through this open. Is string expression. Okay, is string expression represents the path of that file in the host. Then let us come to one example like this. File vectors. File vectors. File name is vectors. Vector is user defined name. Colon bit file. Bit file. It is what type of data the vector file can accept? Only binary data. Open read mode. Open in read mode. That is, you can extract, only the user can extract the data from the file, but not the user can enter the data into the file. That is the meaning. Is some path mentioned here, user home James add.vec like that. So this is a path, the path of the file. Okay, so like that the file declarations and signal declarations, variable declarations and constant object declarations so far we have seen. So these are the 4 classes of data objects we have to hold the data. Okay. Now coming to Another one is data types. Data types. So here we can see what are the different types of data are there in the VHDL language. Okay. Usually the data types also classified into 4 categories. Those are scalar type, composite type, access type, file type. Okay, the 4 classes of data types are scalar type, composite type, access type, file type. Okay. So before going to see the user defined scalar type, composite type, access type and file types, first of all I would like to discuss what are the predefined data types. What are the predefined data types? Predefined data types also comes one of these. It may scalar, it may composite, it may access, it may file types, like that. Okay. But what are the predefined data types are available in the language? Bit vector, Boolean, character, integer, real, string, time, standard logic and standard logic vector. Okay, so these are the different types of predefined data types are available in the language. So far we have seen some simple VHDL programs for half adder, full adder, like that. There we used some predefined data types like bit, we have used bit vector, we have used Boolean, we have used integer, we have used standard logic vector, no vector not used, standard logic we use. So far already these data types we used in the declarations of entities, etc. Okay. So coming to one by one, what is bit? So bit is a predefined data type of it is for the binary type of data. It has only 2 values, 0, 1. Bit vector also to represent a binary data, but in bit vector case more than 1 bit can be assigned. In first one case only 1 bit can be assigned, either 0 or 1, but in bit vector case more than 1 bit. That is, bit vector is an array type. Bit vector is used for the array declaration. Then coming to another one, Boolean. Boolean is a data type. It has 2 values. It also has 2 values, but one value is true, another value is false. Okay. And coming to character. So in character case, as per ISO, 8-bit character set is allowed. Then integer, for the numeric values, the integer type is used. The range, in the integer case, the acceptable range is -2 power 31 minus plus 1 to plus 2 power 31 minus 1. And coming to real is also a predefined data type. It is used in case of floating point numbers case. The floating point numbers case or decimal numbers case, the real data type is used. Then string is also used when you work out on a group of characters or literals. Time, so it is used for representing time related data. Standard logic. Okay, standard logic is generally for the binary data. Standard logic is used, but not only for the binary. It actually the standard logic consists 9 different values already represented here as U, X, 0, 1, Z, W, L, H, underscore. I think U is undefined, X is don't care, 0 is binary 0, 1 is binary 1, Z is high impedance. W I think weak, L is logic low, H is logical high, underscore also maybe don't care thing. I give you the clarity in the later classes. Okay. and another one is standard logic vector. That means in standard logic case only one character, whatever there in the 9 values will be accepted, but whereas in standard logic vector case more than one character or more than one bit can be accepted. Okay, so this is about the predefined data types. In next class we will see how the user can declare his own data type like this. Okay.